Right. Let's mark A. People. Quiet. I want to prepare you guys for the test. You two chatting away. You guys now? I did post it on the group. Okay, but hold on. Wait. Okay, so at exercise 4, it's asking us for each of the following sequences, determine the general rule and hence the 100 term. Okay, so at A, I had 1, 4, 9, and 16. So then I got the difference, which was 3, 5, and 7. If I did it a second time, I got the same second difference, which was 2. And that is an indication that we might have n squared. Okay, now, I don't know, maybe there must be written something after that or in front of that, so let's go and test. What? Oh my word, why aren't you guys telling me that it's not showing you anything? Hasn't it shown anything so far? It's weird, okay. Let me just try and fix. There we go. Okay, thank you. Right, so then we say term n is equal to n squared. But I've got to go and test. Look at the left-hand side now first. Term 1 will then be 1 squared, and that gives me 1. And what is term 1? If you look over here, it is 1. So I didn't have to go and add anything. No. Okay, so if you wanted, you could have tested a second one and said, okay, then term 2, oh, no, wait. Term 2 would then be 2 squared, and that gives me 4. And how much is term 2? 4. Okay, so that was then the final thing to tell me that term n will then just be n squared. Okay, so now I go look at the 100th term. So I go substitute n. Now that's on the right-hand side of the page over here. So term 100 would then be 100 squared, which gives me 10,000. Any questions there? You guys fine? Right, can I skip? Okay, finish copying. Are you done? Who is still busy? Okay, tell me when you're done. Right, can I skip? Okay, let's look at D. So over here I had 5, 8, 13, and 20. So I get the first difference and it's not the same. So then I go and try the second difference and that is then the same. So that's an indication that it would be term n is equal to n squared, but there will probably be something else added, subtracted, multiplied, divided. I don't know yet. No. Then we use something different, and that's only grade 10. Okay. Right, so now we go substitute n. So term 1 will then be 1 squared. Ignore the yellow first, or for now. And that's going to give me 1, but term 1 is actually 5. So how did I get to that 5? I had to go and add a 4 every time. So just go double check term 2 as well. So term 2 would then be 2 squared. Why are you late? Yeah. 2 squared, which gives me 4. And then if I add 4, it does give me that 8. Okay. So my formula, ooh, so sorry. So my term, my term n will then be n squared plus 4. All right. So then they also wanted term 100. So on the right hand side over here, term 100 would then be 100 squared plus 4. Wat gaan hier aan? Would then be 10,004. Okay? Shh, what's wrong? Yes? Why, what's wrong? Want to borrow it? Oh! Yo, burger? Okay. Goed. Can I skip? Any questions? That one is yours, né? Okay. Want ek het iets soos 3 calculators wat ek altyd saam met dra. No, I don't have a pink one. No, mine are all grey. And they usually mark like this at the back and in here. Yes. Run. A what? Okay, right. I'm skipping. Oh, quick, quick. The 2. People, please be quiet. I can't hear. Are you saying 2 over 1? 2 to the power of 1 to the power of 2. 1 to the power of 2. So what I do is I first go substitute into what I've got. I just had n squared. So then I say instead of n, I use 1. So it's 1 squared, and that's going to give me 1. But I know that term 1 is supposed to be 5. So that is why I write the 5 there. And then I go see, how do I get from 1 to an answer of 5? I've got to add 4. And then I know it's going to be n squared plus 4. But then I think that's the answer. So I go double check it at term 2 or term 3, any other terms, just to double check. And if it then works out, then I know that's my formula. Okay. Right. Hands up, you're still copying? Okay. So G. I had 2, 8, 18, and 32. So first difference was 6, 10, and 14. Now, if I do second difference, I get 4. So now I have a constant, not just difference, constant second difference. And because it's a second difference, I know I'm going to have term n is equal to n squared. So please remember that doesn't have to be a 2 to make this a 2. Second difference means it will be n squared, always squared, always a 2. Because I saw some of you when you did homework, you saw that's a 4, so then you make this one a 4 as well. And then it's not right. Okay, so second difference means n squared, always squared. Okay, ask your question. Good, okay. Are you guys all fine with that? Right, so now I go substitute n. I see that, wait, let's take out the yellow first. Right. Okay, so what I do is I use term 1 and then said 1 squared. And that gave me 1. But my answer should be 2. Okay, so it could be plus 1, right? But then if I tested term 2, it didn't work out. So look at term 2. Term 2 means it would be 2 to the power of 2, which gives me 4. Now can I just say plus 1? Not going to work out. So plus 1 is off the table. Then I have to go for another alternative. How do I get from 1 to 2 and from 4 to 8? I have to multiply with 2. Do you guys understand? So if you can't see it at term 1, go write out what it's doing at term 2 and 3, and then you'll start seeing a pattern. Okay. Right, so because we're multiplying with 2, I'm going to have term n is, come on. Term n is equal to n squared times 2. Now you could also have written it as 2n squared. Okay? Now I've got to get term 100. So I say term 100 is equal to 2 times 100 squared. And that gave me 20,000. Yeah. Or you could have said 100 squared times 2. That's also fine, yeah. Okay, so any questions here? Can I skip? Hands up, we're still copying. Okay. You done? Okay. So let's look at J. So 0, 1, 4, 9. Now, if I get the first difference, it's 1, 3, and 5. So it's not the same. So then we go for second difference. Then we've got a constant second difference. No. Which means that I will have term n is equal to n squared. But I might have to add something, subtract something, multiply with something. I don't know yet. No. So let's go and double check. We substitute n. Term 1 will then be 1 squared. And that gives me 1. But my final answer there must be 0. Okay. So it could be minus 1. But now let's go check. If I do the same at term 2, 2 squared minus 1 would be 4 minus 1. And does that give me 4? Oh, sorry. Sorry. It's supposed to give me 1. Okay, so do you see that minus 1 is not going to do the trick? No. Okay, let's just write out term 3 as well, so that with the next step I can double check. So then 3 squared is going to give me 9, and I'm supposed to have 4. Okay, so let's take out these minus 1s because that's not working out for us. Can you guys, if you look at term 1, 2, and 3, can you maybe see a pattern? Yeah. Have a look. Have a look. What I get at term 1, the answer that I get at term 1 is the answer of term 2. What I get at term 2 is the answer of term 3. So can you see my answer is 1 too early? Do you guys see it? Oh, yeah. So it means that, let me just take these out too. So what I want is, I want to take it a term back. Do you guys understand when I say that? So term 2's answer, I get at term 1. So if I want to move a term back, n is most the number of my term. I still want to say n squared, but I want to move a term back, so minus 1. And that squared. Move a term back, because I get the answer too early. Do you guys understand? So now let's go test. If it's then 1 minus 1 to the power of 2, then I'm going to have 0 to the power of 2, and that still gives me 0. And is that the answer that I'm supposed to have at term 1? Yep. Okay, now let's look at term 2. Then I'm going to have 2 minus 1, which is going to give me 1 squared, and that is 1. And is term 2 1? Yep. Term 3 would then be 3 minus 1 squared. That means it's going to be 2 squared, which gives me 4. And look at term 3's answer. It is 4. Do you guys see what I mean? So sometimes it's not enough to just write out term 1 and term 2, because then we're not seeing the pattern. If you still struggle, go write out what you get at term 3 and at term 4, because then in this case, I could have seen it easier. Do you guys understand? So my final answer here would then be term n is equal to n minus 1, but you've got to put it in brackets and then square it. Oh, we could. Friday's one is not a nice one. I can warn you with that. Yes. Okay, let me just finish. So term 100 would then be 100 minus 1 squared, which means that it's going to be 99 squared, which is going to give me 9801. Are you guys fine with that? Exercise 5 was actually an easier one, eh? Okay, can I skip? Alright, finish copying first. Hands up, you're still copying. Okay? You're done. Okay. Right, now before I start with exercise 5, I just quickly want to say that the test that you guys were going to write on Wednesday, okay, that is now postponed. So you are not writing on Wednesday anymore. You are writing on Friday. Okay? Good. So that gives us a little bit more time to revise and to study. So please make sure that you guys score with this test. Because your next test, let me just finish. Your next test is going to be on algebra, which not everyone likes. So if there ever was a time to score in terms of marks, it's going to be in this test. Okay, your hand was up? No. Okay. Shh. Yes. Yeah, still exponents and patterns, but it's just for pride. Sorry? Yes, yeah. Oh, yeah. Yeah. Okay, right. So can I take this off? Everyone knows the test is postponed, no? Okay, good. So let's quickly mark. we are marking 5A. So at A, it says the goalpost nets in the 2014 FIFA World Cup in Brazil were designed using hexagonal, how do you pronounce it, shapes. Consider the following designs made up of hexagons. Number 1, how many hexagons are there in design 4, 5, and 6? Okay, so design 4 would have 12, design 5 would have 15, and design 6 would have 18. Okay, now let's write that as a number pattern. The first one had 3, and then it had 6, and then 9, and then we added now 12, 15, 18. Okay, because at the next question they're asking me determine the number of hexagons in design 200. So to be able to do that, I am going to need the formula. No. Okay, so let's go have a look. What did I have to do here? 3 plus 3 plus 3, and you can see it's the same throughout. So automatically I know it's going to be term n is equal to 3n, but then the rest I don't know yet. No. Okay, so I go use term 1 to find out. So it would be 3 times 1, and that's going to give me 3. And what is term 1? 3. So did we have to go and add anything? No. So we know that our term would just be term n is equal to 3n. You fine with that? Okay, so they want me to get term, this is now number 2. Number 2 says determine the number of hexagons in design 200. So design 200 would be 3 times 200, which gives me 600. All right, any questions there? Okay, then at number 3, they're asking me, which design will have 450 hexagons? So they're actually giving me the answer. They want to know n. No. Okay, so I'm going to say 3n is equal to 450. Now, to get rid of that 3, the coefficient, I'm going to say divide by 3 on both sides, which means that n is going to be how much? 150. Okay, so then just as a conclusion, say term 150 will be equal to 450. Yeah. Therefore. Yeah. Did you guys not know that? I assumed you did. Huh? Oh, if you leave it out, you're not going to lose marks now. Right, can I skip? Okay. Right, hands up, you're still copying? Okay. Good. Okay, so now we're doing C. And at C it says ethnic designs using circles and black oval discs are shown below. Okay, so I'm going to write it as a number pattern already. So at the first one I had 1. At the second one I had 3, and then I had 5. Okay, so already we can start seeing a pattern. Nice. Because, have a look, I added 2 and I added 2. So if you would have to go and write, like they're asking at number 1, the number of circles in design 4, 5, and 6, we were going to add 2, so it would be 7, 9, 11. You guys fine with that? Okay. Now number 2 says the number of discs in design 4, 5, and 6. Right? Now, over there, I have to count the discs at term 1. How many discs were there? No? Have a look. It's circles, and then inside the circle, I've got black oval discs. So at term 1, how many discs? 2. At term 2, how many discs? 6. At term 3, how many discs? 10. Okay. So already I can see that it is add 4, add 4. So now they're asking me to give term 4, 5, and 6. So that's going to be 14, 18, and 22. You guys fine with that? You're not. It's C. And at C, there's 8 questions. Okay? Have a look. It says they use circles and black oval discs. So inside those circles, there's oval discs like that. So at term 1, I've got 1 circle, but I've got 2 discs in that circle. Do you guys get that? Everyone now fine? Okay. Number 3 says the number of circles in design N. So basically they want term N. No, the general rule. But it's for the circles. So I am working with this. Now, are you guys fine with that? Okay, so I'm going to have term N is equal to 2N because the constant difference there was 2. You fine with that? I'm going to write it here. And this was the discs. Okay, so 2N, and then did I have to go and add or subtract something? Let's test. So let's use term 1. So it would be 2 times 1, which gives me 2. But term 1 is supposed to be 1. So I'm going to subtract 1. Let's just quickly test term 2. Term 2 would then be 2 times 2 minus 1, which gives me 4 minus 1, and it does give me 3. So I know that my answer is correct. So term N is equal to 2N minus 1. You guys fine with that? Can I skip? Okay. Hands up, we're still copying?
This one is the same as the other one we did where we said N minus 1 with the term N. Isn't it the same?
This was like we did in the beginning of the chapter, the numeric ones. It's actually geometric and arithmetic. Can I skip? Hands up, we're still copying? Okay. I. Okay, so at number 4, they're asking the number of discs in design N. So now they want me to get the formula for the discs over here, that one. Okay, so can you see I've got a constant difference of 4? No, I'm just talking about the discs now. Okay, so that is why at number 4, I can start by saying term N will then be 4N, but the rest I don't know yet. So now we use term 1, so it would be 4 times 1, which gives me 4. And I'm quickly going to skip back. What was term 1? 2. So what do you think I should do? I'm going to minus 2. Okay, so I think it's going to be term N is equal to 4N minus 2, but let's go and test term 2 as well. So if it's term 2, it's going to be 4 times 2 minus 2, which gives me 8 minus 2, and my answer will be 6. And what is term 2 in that number line? 6. So I know my answer is correct. Term N is equal to 4N minus 2. Right, now number 5, they're asking me the number of circles in design 500. Now at number 3, we worked out that for the circles, no, this is the circles that we just did. No, sorry, circles was at number 3. Sorry. My formula at number 3 was 2n minus 1. So that's the one that we're working with. Now they're asking me the number of circles in design 500. So I'm going to say term 500 would then be 2 times 500, which is going to give me 1,000 minus 1. So 999. Any questions there? Okay, I'm going to write it next to this. Then at number 6, they're asking me the number of discs in design 500. Now the disc formula we did at number 4, and that was term N is equal to 4N minus 2. So all you have to do here is keep track of, are they talking about the discs or the circles the whole time? No. Okay, so term 500 would then be 4 times 500 minus 2, which will be 2,000 minus 2. So 1998. Any questions there? Can I skip? Are you copying homework? Ja, ek lag ook so. Right, number 6. Hands up, you still copying? No one. At number 6, they're asking me, oh no, sorry, number 7. Which design will contain 139 circles? Remember, circles is this one. Yes? Okay, so, yeah. So I am going to say 2n minus 1 will be equal to 139 because they're saying that is the final answer. Give me the n value, no? The design. Yeah. You said 139 is equal to 2n minus 5. Okay, so we first going to get rid of that minus 1. So how do I do that? I'm going to say plus 1 on both sides. Do you guys agree? Okay, so I'm going to have 2n is equal to 140. Now I've got to get rid of that coefficient of 2. So how do I do that? I divide by 2 on both sides. So n, oops, see. So n will then be 70. Over here, the minus 1 plus 1 gives me 0. And then over here, 139 plus 1 gave me 140. Okay, you could have written that out as a step. Yeah? What did you do? Yeah? That's fine, yeah. Okay, now number 8. Number 8 says, which design... Number 8 says, which design will contain 438 discs? So now we're working with the formula of the discs again. So I'm going to say 4n minus 2, and that must be equal to 438. You guys fine with that? I would now write that other step. I'm first going to get rid of this minus 2, so I'm going to say plus 2 on both sides. So you're going to have 4n minus 2 plus 2 is going to be 0, so that's why I don't write anything else there. And then 438 plus 2, which means it's going to give me 440. Now I've got to get rid of that 4. So to get that away, I'm going to say divide by 4, and I've got to do it on both sides. So that means that n will be 110. Yes. It's fine. I could, no. Okay. Can I skip? Okay. I see you guys last period. Let me just check where we are. We are going to be in room 3. Did all of you go? Room 3. Thank you.